Unless, not clearly.
Hello.
Yes, sir, you are audible, sir.
Yeah. Good afternoon, friends, and thank you for the invitation. I just have a very few minutes of time. I'm actually senior data scientist, Tech Mahindra, advisor to SmartBridge. I'm left with only a few minutes of the session, followed by my colleague's session on text analytics. I'll be keeping my speech limited to text analytics for the day. The practical hands-on on the text analytics implementation, NLP, will be implemented by my colleague, Mr. Abhishek. Participants, can you see my presentation? I'll just turn on my link sharing. Can somebody end the previous screen sharing so that I can start mine?
Jaiprakash, I was
Latika,
asking
madam.
you to share this screen before you start your presentation. That's why I was trying to share. So, anyways, I will stop to share.
Okay, thank you. Yeah. I hope now you can see my screen, everyone.
Yes, sir, it is visible.
Yeah. So this
The
time I
volume
want
is a
to,
little bit less, sir, I suppose. It is not clearly audible.
is it so? But I think I'm just pretty perfect on my side. Can you hear me now? Is it audible?
Sir, audible, sir. It's audible, sir.
Yes, sir.
Fine. Thank you. So this is what I am. I am a senior data scientist, Tech Mahindra, Hyderabad, advisory, data science and artificial intelligence, SmartBridge, and many other public sector companies. So without further delay, the time slide is given to me in the leftover. I would have to have a quick talk with the audience and take you all with a journey on text analytics. This is my agenda. Data explosion, understanding data explosion in the 21st century, the challenges associated with the unstructured data, and the quick primer on text analytics with a subtle case study on information retrieval search engine, followed by any quick questions. Well, esteemed participants, we all know that there is a lot of data explosion happening in the century, and there been much light on this data explosion and need for analytics by the earlier speaker. So I just keep it my speech simple that we all have been learning, living in the world, dealing with a lot of structured data. Structured data, as you all know, greatly comes from the organizational information repositories, mostly like file systems, database systems that store data mostly in relational manner. But apart from this available structured data today, the world globally is also becoming more and more matured to handle with unstructured data. But what actually unstructured data means, what are the origins, sources of unstructured data, we'll be discussing that for today. Most of the organizational communication like emailing, the web communication, weblogs, news articles, and the ever-expanding social media powered by internet, these are all the primary sources that attribute to the rise of unstructured data. Unlike the structured, which has some definite levels of measurement to analyze, unstructured doesn't go in a similar style. So the projections from various research studies reveal that the world is definitely going to witness the unstructured platform challenges ahead of their journey. Where do text analytics actually fit into the information technology space? Today, most of the world's businesses are happening online. The websites represent the face of the companies, be it any company, small, large, or medium. The drivers of business innovation are the websites, powered by other secondary sources of communication media. Text mining at its core associates its practices starting from data mining, scaling it to artificial intelligence and machine learning, and further to the most complex textual research using computational linguistics and many others. Information retrieval from documents, classifying the text in the documents, clustering the text in the documents, and whatnot. The real-time web mining are all the essential application areas of text mining in research. But where to begin with text mining? There are many synonyms, participants. Text mining, text analytics are much lookalike terms, but in a broader sense, they are the umbrella terms that encompass a wider range of technologies. What to be done? Well, most of the predictive applications discussed under the data science umbrella or the analytics phenomenon might be concerned with analyzing the structured data patterns. Like if you look into a relational database systems encompasses a lot of tuples, records in a structured table that can be drilled down, sliced and diced, visualized, and analytically or statistically modeled. But are there methodologies in the world today where we can actually also really research upon the text data that is flowing like anything? Yes, my answer is yes. Major areas of research that the world can actually look into is under text analytics umbrella is starting from information retrieval. Primarily, we all use internet search engines in every day of our life for many needs. If you ask different people about why they use internet or search engines like Google, Yahoo, the answer is basically people use search engines for searching for information. A typical question that we all should think is, how do these search engines actually take in the search query? How do they match the keywords with the requisite information and list out the available websites that pop up in the search engine results page? That's one of the most profound area of research with text analytics. Followed by clustering and classifying documents in a large corpus, accommodating millions of words and phrases in text mining, which says that web visitors' footfalls on a website are recorded in the form of several structured and unstructured data. The interactions that a web visitor does with a website, the reviews, the comments posted, these are all coming into the space of text analytics. Information extraction and the phenomenal natural language processing NLP, which shall be greatly dealt by my colleague in the afternoon session with you all. So if you sum it up, the text analytics applications, if you all want to do a predefined research in real-time world, there are much application domains that you can pick up an area for text analytical research, and the tools, the necessary methodologies that are applicable are listed here. For example, if you want to do if you want to learn how a search engine works with keywords, you can pick up the text analytics practice areas such as search and information retrieval. If you want to actually build a predictive model for classifying text in a document, then you can go for document clustering. If you want to see how web crawling actually happens with a search engine with an algorithm, the preferred research areas, web mining, likewise. There are abundant opportunities for researchers, practitioners to dig deeper and dive in the knowledge paradigm of text analytics. Without further delay, let me just take you all with a practical case study. Text analytics, how a search engine actually retrieves information against a search query. We all know, participants, that in the 21st century of the technology era, information is power. Fortunately, this information is made available abundant globally online via internet and retrieved via search engines. Typically, as an internet user, I always have a query with myself. How can we users find information that we want from internet? An answer for this is search engine. Really reputed search engines that we use regularly include Google, Yahoo, Bing, and from others which are well known worldwide. But a point of interest is, how does that search engine retrieve the results that match against our query or the keywords that we have plugged in as input? Let's see the real thing. Undoubtedly, for any information retrieval or search online, search engines actually play a vital role. They try to take a set of keywords or a phrase normally as an input, which might be in a unstructured format by the online user, and try to map it against a list of matching websites or some other kind of result that matches with the input keyword, and list them in the search engine results page. This is all the application that was developed by many of the top companies which have invested a lot worth money, like Google, Yahoo, in their major project. But today, it is our high time to understand the inner working of the search engine with text analytics. As a practice session, I would like to discuss with you all that. Imagine that you all have been given a chance to examine a group of 7 websites participants. Each in there are several text documents like the web pages that are arranged inside the websites. As end user, we are interested in searching for a search phrase such as healthy cat food. The search phrase which we are typing in the Google search engine here in the scenario is a healthy cat food. Now, when we run the search behind the scene, Google searches the millions of websites globally available online, tries to match the keywords and pick up all those websites which essentially display information related to the search query. But how all does Google does this behind the scene, or how Yahoo really handles this query and throws a list of all possible matching searches? When you model your search in a mathematical dimensionality, visualization of the mathematical vector can be represented what you're seeing on the screen. There are 3 words like healthy, cat, and food, which are projected mathematical dimensions along the X, Y, and Z axis, and trying to measure the similarities between these input words against the available information in the web pages. To better understand this mathematical modeling, let's first understand what is text classification. With volumes of text flowing in emails, websites, social media, messages, and many other communication systems these days, there's a lot of plethora of opportunities for you researchers, faculty to examine. Is there a methodology or a paradigm that essentially helps you all to dig out the patterns with machine learning and AI phenomenon or the NLP practices to essentially determine, are there any insights that exist between the flowing text? Imagine you have selected a text phrase, passed it as input and as a training data. The algorithm of the text analytics framework tries to extract the individual words and phrases, calling them technically as features, try to examine the features independently grammatically using a ML algorithm, then encompasses those features and tries to add some numerical values, because text doesn't essentially be understood by a computing machine, because computer machines can understand numeric values only, as we all know. It encompasses this phenomenon in a classifier model so that in future, whatever text flows up in the web pages, the classifier model is able to understand the speech essentiality, the context behind the speech, and then tries to generate a prediction for the future. This is what the fundamental principle that most of the messaging systems like your WhatsApp, when you just type in your messages, several word recommendations are thrown by the application asking you to select it. So this is also one of the fundamental notion followed by the word processing softwares when we do with a spelling and grammar check that pop up, the suggestions that naturally pop up in the application. This is where the actual working of text analytics is really, its appeal is felt. Now, to go ahead with the project, the first step is, let us collect all the data from the 7 various websites. Technically, these 7 websites, we call them as documents in the analytics project. We'll try to accumulate, combine all these documents, and we call them technically as a corpus. So in a simple understanding, corpus represents a large collection of documents containing text. So in the 7 web pages, we are collecting different text fields participants. Like you can see from the web page 1, we have collected a text field. When I spell it, it says as stray cats are running all over the place. I see 10 a day. While in web page 2, the text that we have collected is cats are killers. They kill billions of animals a year. Likewise, 7 different text items were extracted and a corpus was built with this 7 text fields from 7 different web pages. Now, our question is, when we type the search key healthy cat food, what results should come up in the search engine Google? So don't you think that the keywords that we have plugged in will be mapped against these 7 web pages text fields, and the relevancy will be examined and evaluated by the algorithm, and whatever matching criteria are found relevant to the search query, those web pages will appear in a series on the search page. That's the outcome. Okay. Then how that mapping occurs, let us see. Before we begin the mapping, certain pre-processing has to be done on these text fields. The pre-processing includes removing the grammatical punctuations, like most of us in our day-to-day practice during text communication via email or any kind of system, we unknowingly might use some excess punctuation like comma, quotations, full stops, irrespective of whether that punctuation is required or not. Hence, the first step in text pre-processing is eliminate, remove unwanted punctuation, which includes commas, quotations, question marks, or full stops. The second pre-processing phenomenon in text analytics framework is the technical lemmatization or stemming. Stemming refers to removing the unnecessary suffixes. Like if you see, English language is enriched with many rich words. For example, if you take a word play, a kid plays, the actual form of the word plays is play. But during our text documentation, we might use additional suffixes to this word play, and we might describe it as the kid is playing, the kid plays, the kid played. So what are all these words like playing, played, plays? But for all these words, the root word is play, right? Hope you're all following. The root word for the additional words that appear in any language like English normally is the word play in this scenario. Hence, before we take the text forward for predictive modeling like classification, clustering, or a sentiment analysis, it is highly required to cut down the unnecessary suffixes and bring the word to a root form. To achieve this, we use two methods called lemmatization and stemming. Then the next step after lemmatization and stemming is transfer the text to lowercase. If you see many of the writers that publish blogs or develop web pages, content writers, as per the grammatical rules that we follow, the phrase must start with initially capital letter. That is, the first letter must be capital, and the rest of the text mostly will be in lowercase. That means the composition of the text on a web page or a blog or an email is majority a lowercase, except for when a punctuation like full stop ends the phrase, the next phrase begins with the initial capital letter. That's why the most of the text must be represented in lowercase. Sometimes we also represent numbers that might appear suddenly in the text. So that's rare, but when it appears, it is required that these numbers must be removed from the text. Also, due to the human error, while typo errors occur, sometimes we might give in additional white spaces, like instead of a single space, we might accidentally, unknowingly, might give one or two additional spaces, which might kill the professional look of the text. Hence, as part of pre-processing, we'll strip off the unnecessary white spaces and make the text look simple, clean, and much readable and understandable. If we apply this pre-processing framework to our example, now the original text might look something like this. Let's take the pre-processing here. I take initial raw text statement participants, which look something like stray cats are running all over the place. I see 10 a day. This was the first statement which was appearing in the web page one. Now let's apply the framework. Let's remove the punctuation. So when I remove the punctuation, you notice in the second step, we have removed the full stop and we have removed the exclamation mark at the end. Now the statement looks, stray cats are running all over the place. I see 10 a day. Now this is the original text that has been transformed at step one. Now we are asking the text analytical framework tool to stem the terms to the root form. So cats, do you think is a singular or a plural in English grammar, participants? It's a plural, right? But what is the singular form of the cats? It's called cat. So the process of converting a word in a language to its root form is called stemming. Hence, we can further simplify the language by converting the term cats into the root form, and henceforth we obtain the text as stray cat or run all over the place, I see 10 a day. Normally, the natural characteristic of a cat is it runs all over a day. Hence, to represent that, we may not always use the plural cats. We might represent that cat runs all over a day is essential to describe the nature of other cats also. Now, taking it a bit forward, we also have a number. If you see in the previous sentence, I see 10 a day. Do you think 10 cats only run a day? Other cats also run a day, right? So 10, the number, doesn't make much sense here. Hence, we'll remove that number also, and we can make it all stray cat run all over the place, I see a day. Now, as per the framework, we need to convert the text into lowercase to stray cat or run over all the place, I see a day. It's already converted in lowercase. And in between, if you notice any additional white spaces, remove them, and finally make your text ready for analysis or modeling, which you're seeing at the end. Stray cat run all over the place, I see a day. This is the cleaned text or the pre-processed text, which is ready to go further a step ahead for predictive modeling. Now, coming to bag of words, the tools, there are a set of tools apart from the stemming lemmatization. The next tool in the text analytics framework is BOW, bag of words. Essentially, bag of words, when applied on the cleaned text, tries to count the occurrences of the words in a document or in a corpus and tries to sum them up and beautifully show that summed up count occurrences in a matrix called term document matrix. To understand this phenomenon, participants, let us take 3 documents. I hope you're able to see on my screen, there are 3 documents, document 1.txt, document 2.txt, and 3.txt. Document 1 contains a phrase which goes like this: statistic skills and programming skills are equally important for analytics. Document 2 contains the phrase statistic skills and domain knowledge are important for analytics, while document 3 contains a text, I like reading books and traveling. Now, observe carefully from the 3 documents and let us try to build a matrix with the word frequency, that is the count of words with respect to all 3 documents. If I take the word analytics, how many times the word analytics appeared, and did it appear in all documents? Let us count them. By the illustration, it is pretty evident that the word analytics appeared in document 1, document 2, but it didn't appear in document 3. That's why the count is noted as 1 time analytics occurred in document 1, 1 time it occurred in document 2, 0 times it occurred in document 3. Such a collection is called the document vector. Individually, the frequency of the word appearing in 3 documents is a word vector. Similarly, if you see the word statistics, participants, can you tell statistics how many times it appeared in the corpus? Corpus means all 3 documents put together are called corpus. In general, a corpus is a collection of n documents, n large number of documents. So by observing carefully, we can see that statistics appeared in the first document. The word statistics appeared in the second document. So a count of 1 noted for each document respectively, and the statistics word doesn't appear in the third document. Likewise, for each term, we are building the count of that word in each document, and together this representation is called term document matrix. But you might think, why we have to count the frequency of each word? Does it add any value during the text analytics or modeling? Certainly. For example, in the real-time applications, we all use every day, like a word processor, that might suggest us in case of a spelling error or grammatical error, or a communication messenger like a WhatsApp, like when we key in the message during our chat, participants, the relevant words that were used in the earlier communication are memorized by the application and are referenced in the next subsequent communication. That's why whenever we type, surprisingly, we see some recommendations words which we actually didn't know are referred, are suggested as the next word to be used in the phrase or the paragraph. But how does that application works? Very smart. what kind of intelligence was given to that application? This is the basic. So initially the words are examined by the document vector and are calculated, tabulated as a vector document term matrix. Now, likewise, in our project, search engine also tries to map the input keywords given by the user against a set of all matching keywords found in different websites globally and prepares the term document matrix. Now, the word cat, what we are asking, healthy cat food was our search query participants. The word cat, if you compare, it appeared one time in web page 1, one time in web page 2, it didn't appear in web page 3, twice it appeared in web page 4. If you want, I'll just go back and show it all here. So our search query was healthy cat food. Now Google is taking the word cat and trying to compare with 7 different text fields. As you know, the word cat appeared here one time. As we have stemmed, the word cats will now take the root form cat. So the occurrence frequency using the bag of words was counted as 1. Similarly, the word cats appeared one time in document 2. And if you see participants in the 3 and 4 and the 3 especially, there is no word cat. But if you see the web page 5 or the text field 5, how many times the word cat appeared? It appeared one time here, and other time. So the frequency of the cat, word cat or the term cat, is found greatly in web page 5. So normally, think psychologically and answer, do you think now Google search engine must pick up web page 5 as the term cat has more frequency in web page 5 and show web page 5 as the first search result participants? What do you say? Right? So the search engine algorithm crawls through this text field and computes the frequency of the word cat and evaluates that the word cat occurred 3 times, and it tries to pull the web page 5 at the topmost position. But if that were so, does this web page field or the text field in the web page, does it really matters to cat food what the user was typing in the query? That also should be evaluated. It doesn't mean that compare the outline of the term frequency and then make a call that this web page should appear on the first. No, that's not the game. You must check context sensitivity and the matching keywords that makes the website appear. So a lot of information analysis happens behind this project. Hope all of you understood the term document matrix that was calculated by the Google search engine algorithm using text analytics framework that was embedded in the algorithm. Now let's go ahead and check the term documents. In the bag of words, we just now understood that the bag of words was able to calculate the term frequency. But mathematically thinking, term frequency might not always be same for a word in all different web pages. It varies. Hence, a recommended strategy is try to apply some mathematical transformation to get the actual weight of the term. In order to do so, recommended techniques are apply a square root of the term frequency or a logarithmic transformation of the term frequency. So when we do this, what happens? Let us see. To understand term frequency, I'll give a quote and example. Term frequency will tell you how frequently a term appears in a document. But why we have to calculate term frequency? What is its importance? Let us see. Mathematically, term frequency is defined as the ratio of number of times a term appears in a document to total number of terms in the document. This is the mathematical formula. To understand it, let's take an example. Imagine, participants, we have a document containing 100 words, in which one word called ML, that is machine learning, is appearing 3 times in the entire document of 100 words. Then the term frequency for the word ML can be calculated as number of times the term is appearing, that is 3, divided by total number of words in the document, that is 100, which evaluates to 0.03. This is the term frequency. Right. Imagine the same word ML is appearing 10 times in the next document. In the next document, in which there are also 100 words. Then if you calculate the term frequency, 10 divided by 100, it should come to 0.01. So the frequency of the same word ML varies from one document to other. Now this becomes a very challenge for the search engine algorithm to determine which web page or which document should it consider to list out on the first page of the search engine results page. Should it go for the first document with a term frequency 0.03, or should it go with a second document where the term frequency of ML is 0.01? So there's a lot of debate going on by the algorithm here. Now, apart from term frequency, you should also know an important phenomenon called document frequency also. Now, document frequency is mathematically defined as the number of documents containing a given term divided by the size of collection of the documents, that is the corpus size. Now, to understand this, let's just look into the example. Imagine if you have 10 million documents with you, and in that corpus of 10 million documents participants, if the word ML is appearing in 1,000 documents. So in a massive corpus of 10 million, the word ML is appearing in 1,000 documents. Then how will you calculate the document frequency? It's simple. The 1,000 times the ML word appearing in the 1,000 documents ML word is appearing divided by 10 million, which would around to 0.0001 is the document frequency. Now, what is the actual essentiality of these two phenomenon, term frequency and document frequency is? Again, the document frequency of ML might not be same in other documents also, or in other corpuses. Hence, a better practice is, let us transform this document frequency into a normalized form by applying a logarithmic transformation. When we apply the logarithmic function on the document frequency calculated so far, we would get a normalized document frequency. For instance, in the scenario, it evaluates to -4. So why we are doing this logarithmic transformation on term frequency or document frequency is to keep, irrespective of the frequency, physical frequency of the word which appears in many documents in varied form, let us take the logical frequency. Let the word ML might appear 3 times in first document, 10 times in second document, 100 times in third. Let us, the algorithm doesn't get biased or confused at the end. Is it the frequency? Is it the physical frequency that I should consider about the term and pull that website first? If it is so, might be the pulled out website might not contain relevant information as needed by the search user who has given the search query. Hence, to give the relevancy, to maintain context sensitivity and relevancy, it is always required to pick up the normalized form of the text. So when we apply logarithm, the formula just goes, numerator becomes denominator and vice versa for the document frequency. So logarithm of total number of documents divided by number of documents with the given term. So logarithm of the 10 million divided by 1,000 to convert the value into positive 4. Finally, the term frequency, and this is called IDF. IDF stands for inverse document frequency. The TF IDF for the term ML when calculated would attribute to multiply the term frequency multiplied by the inverse document, which will give you called weight or score for the web page. Likewise, Google calculates scores for each of the web pages, and that web page which gets the highest TF IDF score participants. Remember, the TF IDF score after normalization shall be the first website to appear in the search results page. I repeat, after converting the text into proper numerical count with the bag of words term document matrix, the next step is calculate the term frequency and inverse document frequency, and then calculate the total TF IDF for a particular term, the search term, against a set of corpus documents, and then list out the scores. What you're seeing 0.12 is technically a score which the search engine assigns to the different web pages. That web page which gets the highest TF IDF score for a given search phrase or a search word shall be the first website or the web page to appear at the top position. This is how text analytics is playing a vital role in information retrieval and information extraction, and helping search engines like Google and Yahoo to really keep their online visitors happy and get them the required information that they actually are searching on for the World Wide Web. So I hope participants, you are clear about the today's discussion. Uh, Coordinators, if you are there, now I open the floor for a quick Q&A. Participants, if you have any questions on the discussion so far, you are welcome, ladies and gentlemen, to raise your questions.
No questions.
Okay, fine. So that's all for this thing. Thank you.
Excuse
for
me, sir.
extending the.
Excuse me, sir.
Yes.
I have a question.
Yes.
Sir,
Yes.
sir, what is ISF?
Come back, madam.
What is ISF? जैसे IDF होता है सर, वैसे ISF होता है. So I have a doubt in this term, IDF and ISF.
See, when we deal with text analytics, there are many phenomena that we have to consider, right from word tokenization to phrase tokenization to, I mean to say, calculating till IDF. Based on the nature of the data that you get, like document frequency is most associated with the text formats. Likewise, unstructured data might not always only available in text format. It might be an audio, it might be a video format, it might be other signal oriented formats like an electronic signal, that a wave that might be obtained from a equipment, right? So to handle the unstructured data formats, several paradigm statistical mathematical notations are available to understand the occurrence of that data parameter in the problem. Okay, so many other parameters, but for this session you can try to keep in mind the term frequency and IDF actually play a lot of role. Hello. Yeah, any other questions? So the selection of the tool, I say, it depends on the kind of data that you are trying to project or predict. Yeah. Any other questions, participants? Hope everyone is familiar now with the how the Google is actually working with the text analytics, information retrieval frameworks, and throwing abundant of websites as a search engine search results outcome. If anybody wants further to go ahead, you can ask, or if you're all done, that's good, pretty good.
Participants, you may type your question in the chat box also. Mohan sir, if you can share your mail ID with the participants,
Yeah.
so that they may contact in future, whatever, if they are having any doubt.
Definitely. So dear participants, this is my mail. You can reach me on, write to my mail regarding any queries or further needs on research related to text analytics, information retrieval, or any space in data science, artificial intelligence, ML. So that's all from my side. Thank you all for extending the invitation and listening to me patiently in the little time. Good. Okay.
Thank you, Mohan sir. Thank you for the wonderful session.
Yeah. Thank you, client. Thank you, SmartBridge, for extending the invitation. See you all.
Thank you, sir. Participants, we will have the next session from 2 o'clock. Now it will be a lunch break.
Okay, ma'am. Thank you.
recording end कर दो